Hi everyone, this video covers the implementation of User Datagram Protocol, also known as UDP. We'll go over what UDP is, which applications it's used in, and how we implemented UDP protocol within FPGAs. This project was done for a networking class at San Jose State University. My partners for this project were Karan, Aditya, and Evan. The key aspects of the project that we wanted to highlight were the checksum, multiplexing, and demultiplexing capabilities. We decided to use two of the Igloo Nano development kits, along with the Libro version 11.3 design suite. All of the programming was done in Verilog. The two boards that we used are shown here. One of them acts as a sender, while the other one receives the information. We use switches and push buttons to input the information, and we use LEDs to view various information such as port numbers, data, errors, or checksum. So what is UDP? UDP is one of the two basic transport layer protocols, with the other one being TCP, or Transmission Controlled Protocol. Compared to TCP, UDP is faster, simpler, but the downside is you may have segment loss when you're trying to transmit data. There are applications out there which require fast transmission, such as video chat or Skype. You want the video to stream as fast as possible, but don't mind if it hangs for a moment. This would not be possible in TCP. The UDP segment format has four basic header fields, which are 16 bits each. This includes a source port number, destination port number, length, checksum, and data. The data field can be of variable length, but for our project we decided to keep this at a fixed 16 bits. So this is a high-level representation of our project. We have a source FPGA, which is sending data segments to a destination FPGA. Both of the boards use switches and push buttons which interact with the logic, which in turn displays data on LEDs. Of particular importance to us are the status LEDs, which tell us the source port number, destination port number, and error bit. On this slide we could see how the switches and push buttons interact with the boards. By toggling through the switches, we could view the data, checksum, display status, or even introduce an error bit. The push buttons correspond to which port number the data will be sent to. This slide will be of particular importance to us during the demo, which will be shown in a different video. Here's a block diagram of the source FPGA. I'll be going into more detail on this slide compared to the destination FPGA, since the destination FPGA is pretty much a mirror image of this block diagram. On the left we can see we have 16-bit fixed data, which is stored in the memory. We use switches 6 and 7 to select a port number, which is anything from 0, 1, 2, or 3. And then we push a push button 0 through 3, which corresponds to the destination port number. Now this goes through an adder, it goes through a ones complement block, and at the end we have an option to introduce an error, which is switch 5 on the source FPGA board. Now the data gets broken into 10 8-bit segments, which go through a MUX and get sent serially to the destination FPGA board. We also have an option of viewing the data on the source FPGA board through our LEDs. We could use certain switches in various positions to view this data. You can see the block diagram for the destination FPGA is pretty much a mirror image of the source FPGA, in that you receive the data 8 bits at a time, and then certain data goes through certain adders. This helps compute the checksum. If the checksum is all ones, that means we receive the correct data. If the checksum isn't all ones, then when we go to view the data, the LED should blink. And this is highlighted in the demo that we'll be showing later on. And again, like the other board, we have an option to view certain data, like data checksum or the display status bits, which shows the port numbers and error bits. So we could view all that on the LEDs on this board as well. Now let's get into the demos. Okay, so now begins the fun part of the demonstration. I've programmed both of these boards using the Flash Pro software. I programmed this one using the sender code, and I programmed this one using the code for the receiver that we wrote. So what's going to be happening is we're going to be sending data from the sender to the receiver. And within this, I'll be demonstrating three important aspects of the UDP protocol. The first one is going to be sending and receiving data through certain ports. Next one is going to be verifying the checksum. And the third one is going to be introducing an error before we send the data, or as we send the data, and we could view what the receiver does with the data that contains the error. So for the first demonstration, I will be sending data from the sender board, receiving it on the receiver board through a selected port number. So on both boards, I have the display status bit set, and this bit allows us to view the source and the destination port numbers, and also to see if an error is introduced. So let's say we want to send from port number 3. So we would turn on these last two bits, which is a binary 3. As you can see, these two LEDs light up, which means it's sending it from port number 3. And we could pick which destination port we want to receive it on. So this is 0, 1, 2, and 3. Let's try sending it to port number 2 right here. Good. So we see this LED turn on, and this lets us know that the data will be received in port number 2. So as we push that button, or this button, the data was sent instantaneously. So now we could look at the destination board. And the first thing we could check is if we've received anything on the other ports. So we could check port number, port number 0 first. We haven't received anything. We could check port number 1. We haven't received anything. And same thing with port number 3. However, when we check port number 2, we get the matching indicator, or the matching display status, telling us that the data came from port number 3 and we received it at port number 2. So we could go back to the sender board and see what data was sent. So we'll turn the status bit off. We could see the data, or the first 8 bits of the data. We could see A5 was sent. And then we could go back on the receiver board and confirm that. So we'll turn the display status bit off, and we could view the first 8 bits of data, which is 5A, and we could verify that they both match. Now that we've confirmed that both of the boards display status matches and the data has been sent correctly, we could verify the checksum on both of the boards, or I'm sorry, this receiver board. So when we check the checksum on the receiver board, what we should be seeing is a string of all ones. So all of the LEDs should be on. And there you go. And that confirms that the correct checksum, or correct data, has been transferred. So in this demo, I'll be demonstrating how the UDP protocol handles an error. So as with last time, I have the display status bit set on both of the boards, and this will show us the source and destination port numbers as well as an error. So this time, let's say we send data to port number 2, shown by that LED, and let's introduce an error by turning on this bit here. So this green light indicates an error has been or will be introduced once the data is sent. We could send it to port number 3, for example. There you go. So once we receive the data here on the receiver board, the display status should match, which it does. However, if we try to check the data on the receiver board, it shouldn't be the same data as we saw last time, since this green LED is indicating there was an error. So let's check out the data. Yep, the blinking indicates erroneous data has been received. And when we check the checksum, we could see that it's not all ones. So if correct data was received, we should have seen all of the LEDs light up. But since not all of them are lit up, that means we know there was an error.